Assalamualaikum students. Today's our topic is Rolle's theorem, mean value theorem. We will discuss detail in the lecture number 9 calculus. I will put link in the description. Just we will discuss definition and some examples. Rolle's theorem. Suppose a function is continuous in closed interval. When we say closed interval, it means boundaries are included, and differentiable on open interval a and b. In open interval, boundaries are not included. So if we put boundary values f of a and f of b, and it is equal, f of a value is equal to the f of b value, then there exists a number c in the open interval ab for when derivative taken of the function f prime of x, and put the value x equals to c and first derivative put equals to 0. There are three conditions. Rolle's theorem has three conditions. One is f of x is continuous, which we study in the definition. F of x is differentiable. Here we can study f of a equals to f of b. If three conditions are whole, then Rolle's theorem can be applied. Otherwise, if any one of these is not applicable, then our theorem is not applicable. Just like an example, f of x equals to sine x, interval 0 to 2 pi. F of x is continuous on closed interval. F of x is differentiable on open interval. F of a equals to f of b. Third condition, now we check third condition. Put f of x, f of 0, sine 0 equals to 0, f of 2 pi equals to sine 2 pi equals to 0. So f of a equals to f of b. So f prime of x equals to derivative of sine is cos x. F prime of c equals to cos c equals to 0. As we know, f of a equals to f of b, then put f of c equals to 0. So c equals to cos inverse 0 equals to 90 degree. Another example, f of x equals to x square plus 6x minus 6, interval 1 and 5, 1 to 5. F of x is continuous on closed interval. F of x is differentiable on open interval. Here you can see f of a is not equal to f of b. When we put 1 in the function, our answer is 1. When we put 5 in function, then it gives 49. So third condition are not satisfied, so can't apply Rolle's theorem. Here you can see another example, f of x equals to x cube over 3 minus 3x. Interval is this. F of x continues on given interval, differentiable on open interval. You can see when we put minus 3, it gives 0. When we put 3, it gives 0. It forms 0 over 0 form. F of a equals to f of b. So we can apply Rolle's theorem. Now you can put f prime, because we have f of x equals to f of b, so we put f of c equals to 0. You don't need this to write f prime of c equals to 0. We take derivative of this, then put x equals to c, so it becomes c square minus 3 equals to 0. c square minus 3 equals to 0. We take minus 3 on other side and minus become positive. Then we take radical. So c equals to plus minus radical 3. Mean value theorem. Suppose y equals to f of x. Function is continuous on closed interval a and b and differentiable on open interval a, b. Then there exists at least one point c between this interval. Then we apply the formula f of b minus f of a over b minus a equals to f prime of c. You can see some examples. Means value theorem. F of x equals to sin x 0 to 2 pi. Putting 0, f of 0 equals to sin 0 equals to 0. F of 2 pi equals to sin 2 pi equals to 0. You can calculate from calculator. Your calculator should be in degree form. Now you can see f of x equals to f of b, or you can see it is continuous and differentiable on the interval. So you can put this formula f prime of c equals to f of b minus f of a over b minus a. So f prime of c equals to cos c, putting the values f of b minus f of a, which is 0 minus 0 over 2 pi minus 0. Here you can write c. C equals to cos inverse 0, because we have cos c equals to 0. Then you take cos on the other side, it becomes cos inverse 0, c equals to 90. Now you can see this f of x equals to f of x equals to x square plus 6x minus 6. When we put interval 1, it gives 1. When we put 5, it gives 49. F prime of c equals to f of b minus f of a over b minus a. So our f of x equals to 2x plus 6. Then we put in the formula. So f of c equals to 49 minus 1 over 5 minus 1, which is equals to 48 over 4. Then we take divide or cutting, which is equals to 12. So it becomes 2c plus 6 equals to 12 and c equals to 3. Now we have third example. F of x equals to x cube over 3 minus 3x. On this interval, put minus 3 in the function, it gives 0. Put 3 in the function, it gives 0. F of c equals to f of b minus f of a over b minus a. So you take derivative of this, it gives 3x square over 3 minus 3, which is equals to c square minus 3 equals to 0. Then take 3 on the other side, so c equals to plus minus radical 3. Thank you for watching this video, and please like this video, share with your friends and subscribe my channel